Now today we're going to look at power series. So we have do all the revision for the previous concept, and now this morning we'll learn about something that top up from the previous concept. So as you can see here, the title there is power series. What I mean by power series? You will see in this form. So this is a general equation for power series. As you can see here, what is different from the previous series that we talked about? So this one, as you can see here, I label the something with color. So when we talk about power series, you are focusing on the x. There is an unknown there. Okay, there's an unknown x there compared to the previous one. Okay, and then you can see the first one is C sub 0, means it's a constant value, your first constant value. Okay, your first constant value. And the equation for power series as a far left there, you see C sub n x power n. So that is a power series pattern. Okay, so this morning you need to recognize the new form of mathematics. We call it power series, where when you want to add all the power series together, or want to add all the algebra with the x power something together, then you use this equation. Okay, so something new this morning. All right. So again, start from today, we will look at variable x. Okay, there will be variable x inside your calculation. And I label, just a side note for you, all the C here is a constant value. We call it sometimes in the question, we call it coefficient, right? Coefficient means a constant in front the x. Okay, so here you have, in this equation, you have C0, C1, C2, C3. All these are called coefficient. So we have introduced you the definition of power series equation. What we can do with this? So combined with what we learned previously, there's one power series. If we can write our series in the function form, okay, you can write the equation from C0, C1, C2, C3, right? The operation that you do to add all the numbers together in power series, right? You can see the right hand side of the equation is the same, right? This part and this part is the same. Only the far left there, you see there's a f bracket x. So we can write this whole power series as a function. Okay, this one as a function. How you communicate with mathematician that you are meaning function? You use f bracket x to represent you are writing a function. Okay. Okay. And in power series, we are focusing on convergent pattern. Okay. We need to make sure that always we get a convergent behavior, or in our either in our function or in our power series. Okay. Any question? No, eh? So far, everyone okay?
No, sir.
All right.
Okay.
Now, we start with something simple. If Cn, the far left equation for power series, again, power series pattern, the equation is C sub n x power n, the far left, you see, behind the, just beside the sum symbol. Sorry, my finger cannot go further, right? So if you want to say something about power series, you use the equation of C n x power n, x power n, right? So what happens if your Cn is 1 for all the n? Okay, you can write the power series become this one. If your Cn is 1, okay? If your Cn is 1, what happened to the power series? Means that your Cn 1, and then you start with the first one. How you calculate the first number? You use the equation of C sub xn, and then you replace the yellow color n in the equation, yellow color in the far left equation, right? Just on the top of the x, you see the yellow color n. You replace the n with 1. So x power 1, you will get, sorry, not power 1. For the first one, our n is 0. For the first number in power series, our n is 0. So as you can see here, our first number, we get 1 there. Okay, how we get 1? Cn equal 1, x, and then n is 0. So x power 0, you have the something x here, okay, something x in the equation, and then your n is 0, you'll get 1. So 1 times 1, you get 1. And then you go to the second value. Second value is 2. Second value, your n is 1. And then you get x. Okay. Then the third number, you can see the third number become 2. So your n is 2 when the position is number 3. Okay, so it's a little bit different from the previous concept that we learned in series. So in power series, there's a different pattern here already. Okay, previously, if your number 1, your n is 1, but however, when it comes to power series, you can see the first one, the first number in the equation, okay, in this equation, always is a constant value. In this case, is 1. Okay, in this case, is 1. So this is under power series. Okay, so recognize the pattern. Today, I want you to learn how to recognize power series pattern. It is a bit different from the previous lecture that when we talk about series. So today, we learn something new about power series. Try to recognize when you talk about power series, the first one in the calculation always a constant value. In this case, is 1 because we assume there's a condition there. We say Cn equal 1. So the first one is 1. Okay. And from this general equation on the top, if we say Cn equal 1, it will become geometric series. Okay. If this is the general equation for power series, and if we say we set a condition Cn equal 1, then we will get a geometric pattern. This becomes geometric pattern. Okay, and it converge. Now, geometric series we already discussed in the last class. So if you change your Cn in this power series general equation, it will become the pattern you see in geometric series, and it converge. Previously, for geometric series, we already discussed about geometric series in the previous class. So if you cannot recall, go back to the video that we discussed about geometric series. Okay, so we have already proved that in the geometric series, the data, the series will converge between -1 and 1. This one we already done, right? We already show you why this one works. Okay, and diverge in when x more than 1 or equal 1, and so on. So we this morning again recognize the pattern of power series, and this one is just you need to read the question. Right? Important you recognize this pattern. This is the general equation for power series, and then you need to read the question. Sometimes the question give you what is a Cn. So in this case, we start with Cn equal 1. You get this. You convert this one into this one. Okay, and remember the first one, the first number in the power series, the n start with 0, not 1. So just be careful on that. Okay, so don't confuse with the previous series that we learned. So in power series is a bit different from the general series pattern. Okay. Now, what happens if you replace x? You replace your x. Just now we play with Cn. Just now we play with Cn. Now we play with x. What happens if you replace your x? You replace your x. Again, look at this pattern. This pattern is when we have Cn equal to what? We get this pattern. Nizam? Nizam, is there?
Sir?
This one. Yeah, so this one, our Cn equal what? You get this one in our power series pattern.
C.
This is our general equation for power series. What happened to the equation when you can arrive at this equation? What happened to your Cn? Cn equal to what? If you want to get this pattern.
Cn equal to 1.
Yeah, Cn equal to 1, you get this pattern. So we continue playing with this equation. Yes.
If it is 1 or if it is constant?
Again?
If you're telling Cn equal to 1,
Mm-hmm.
what if it is constant, like same numbers? No, cannot be.
Yeah, I mean you replace your Cn, means in power series, do you see the general equation for power series?
Yeah.
C sub n x power n. So now your Cn, all the Cn is 1. Then you continue changing your n only. You continue changing your n in the equation, this one. So that's why all the Cn in the equation is 1. Then the first one is Cn x power n. N is 0. So that's why you get 1 there. That's why you get 1 in the equation. Then you look for second number. You know that your second number Cn is 1. So actually your C1 here is 1. So you will get second number x here because your n now become 1. Okay, so need to recognize the pattern. This is a general equation. Then be careful what happens when you play with a power series. Your n, when you write the number, the data number here, your n is no longer, is always -1 from the location. Okay, and we always start with 0, n0. The first one n0, second one n1, third one n1. Then the fourth one n2, n equal 2. So have observation what happened to power series. So this is important for this morning. Okay, now we continue to play. Just now we set Cn equal 1 in this general equation. We get this pattern. Now what happened? We play with x. We continue using Cn equal 1, and then now we change x. What happened? Okay. Now what happened if we continue following the convergence criteria? Our x is between this value, so that our data, our series, at the end you add all the number together, you get a convergent data or convergent series. So we pick one value in the middle. So what happens if your x equal to half? Half meeting this criteria. X is between -1 and 1. So x is convergent, right? X value will give this set of data convergent or converge. So what happened to our equation? So you continue using the equation. So x power x now is half, because why the c sub n gone? Why we do not write c sub n here? What is the value of your c sub n? 1, right? So you don't need to write 1 here. You are repeating the same meaning. So actually there's a Cn over here, but Cn value is 1. Okay, Cn value is 1. So, and you compare the equation of far left, Cn 1. So that's why here we do not write 1 here. Actually there's a 1 here, Cn here, times your x Your x now, you assume is 1 over 2 and then power n. What happened to the data? You see, now we are talking about power series. Don't confuse with the previous class when we talk about general series. Now we talk about power series. Look at the first number, the first green number. A read special from power series. How you get 1? You look at this equation, this half power n. How you get 1? You n must equal to what? Nizam? Half power what equal 1?
N must be first number 0.
Yeah, correct, 0. So half power 0, you get 1. How you get 2 when your n equal to Shakir? How you get half in the second number? What is your n number? N equal what to get half? Shakir? Shakir first time. Shakir second time. Shakir third time. Shakir not in the class. All right. Edmund? Edmund, are you there?
Yes, sir.
Okay, Edmund. Second number. How you get this equation? Half power n to get half, to get 1 over 2. What is your n number? N equal
1.
what to get n equal to 1? Okay. Now, I give Shakir one more chance to respond. Shakir, are you in the class? Shakir, one time.
Hello.
Yeah, Shakir. How you get 1 over 4? What is your number n? How do you get 1 over 4 from this equation? So when your third number in the power series, your n become 2. Okay, 1 over 2, 1 over 2 power 2, you get 1 over 4. And then you look at number 4, the fourth number. Now the fourth number, your n is power 3. Do you see the pattern is a bit different from what we learned previously in series? The n will always minus 1 when it comes to power series. Recognize this pattern. Recognize this pattern. Shakir, you need to off your mic. Your mic is making noise to the class. All right. And what happened? We already proved that when your x is more than 1 or equal 1, this data will become diverge. Okay, this data will become diverge. You can prove lah. Okay, but we already done this one in the previous class. Okay, we will get infinity. So let's try. What happened to when your x more than 1 or equal 1? Let's say you set x equal 2 in the equation, power equation here. Okay, and your Cn still 1. What happened? So you can see we change the equation here into 2. Again, in front 2 is 1 because we assume we already set the condition Cn 1. So in front here is 1. In front here is 1. And we play with the x. X now we set as 2 to prove that we will get divergent series. So what happened? 2n, because our x now is 2. Okay, look at this general equation. Now we replace x is 2, n equal. Again, you see, power series is very interesting. The first one, you n always 0. You n always 0 for the first one. So 2 power 0, you get 1. Because anything you power is 0, you get 1. Plus, how you get 2? Second number, your n is 1. Okay, always minus 1. Your n always minus 1 for power series. So you see, 2, how you get 2? N become 1. How you get 4? This is a third number, but third number in power series, you need to minus 1. So third number minus 1, 2. 2 power 2, you get 4. How you get 8? The fourth number in the series. Fourth number always minus 1, so your n is 3. So 2 power 3, you get 8. And then dot, 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 dot. Try to see how when you get, try to add all this number until infinity. You will get infinity. So when you get infinity, your series is diverge or divergence. And you look at this green color one. When your x is between -1 and 1, and in this case we use half to represent our x. As you can see here, if you increase your number, the number becomes smaller and smaller. Okay, becomes smaller and smaller. Half, 1/4, 1/8, and so on. Very smaller and smaller. So when you add together, you will get very near to maybe one number. Okay, one solid number, because the at the end of all this number is very small number. Okay, so eventually you will reach one solid number. If you plot graph also, you'll get a converge graph. This one cannot. This one it continue to get bigger and bigger. So from here, we prove. Do you see the pattern of the power series? One interesting power series. The first one always 1. The power series, the first number in the number always 1. Or in your power series data, when you want to add something, when you see the equation or the working, when you're working, you want to add numbers together. When you see 1 in front, it means high possibility. High possibility, it is under power series. This is how you recognize series. Okay, so I teach you already how to recognize power series. The first, most obvious one, you start with 1. No matter how you change the equation inside the general equation there, you always get 1 in the first one. Because in power series, the n here always start with 0. n0, you always get 1. n0, you always get 1. And so on. Any questions so far for power series? Any question? Edmund, you okay?
No problem, sir.
Okay, good. Let's look at another one. Okay, so we have done with the general formula. And then I show you the pattern. And then we discuss about converge and diverge scenario. Now let's look at what happened when your x is minus a. Now our a is our x. Just now our x is very clean, only x. Now what happened if we change our general power series here, our x here, we change a little bit. We change this one to x minus a. We replace this one x minus a in the general equation. So you can see our equation changed a little bit. We replace our x become x minus a, and then the first one we label as c power c sub n, means 0 means initial. Initial means starting point. Okay, cn plus c1 x minus a x minus a2. Okay, you see cn. Of course, you can write c0 x minus a power 0. You still get 1, right? And then x minus a power 1, you get this whole set. Then the next one, x minus a power 2 times c2, and so on. So this is a power series pattern. As a power series pattern. Okay. Now, this pattern, okay, this mathematics equation, what does it mean to you? It means that the power series is centered at A. Is centered at A. A is a 1 value, or the power series is about A. Means the power series will mingle around this number. Okay. All right. So what happened if your, look at this one. Huh? What happened when the first number is without, you don't see this one, right, in here, but you know that the first number, your n is always 0. That's why you get 1 here. C0, 1. C0 times 1, you get C0. So it means I circle the first one when our n is 0. So that's why you get 1 there. So you substitute your C0, X0, and now you replace your X. You replace your X in the general equation just now with X minus 1. You replace these things inside here, inside X. You'll get X minus A power 0. Then you get 1. Okay? This is how you get. So, yeah, so constant value will always give you 1 in power series. Again, this one is just an extra explanation. When we talk about power series, the first number always 1. Just give you an idea. So when you look at the numbers, look at the a series number, and you want to add them together, the first one, the first pattern you look is whether the first number is 1 or not. If it's 1, very high possibility you are solving power series pattern, power series question. Okay, yeah? So this is how you solve question. Okay, this is just extra explanation. So no matter what happened inside here, no matter what is the value of your x, even you get 0 here. Okay, when your x equal a, you get 0, right? A minus a, you get 0. 0 power 0, you still get 1. Okay, either you get a negative value, positive value, you power 0, you still get 1. So this is just extra information to remind you. Even you get 0 inside a comma, inside this bracket, you still get 1. What happens if your n more than this in this equation? If your n here, the yellow color n here, n is more than 1 or equal 1, when x equal a, what happened to this equation? Will it converge? If you increase your n, try have a look in this equation. What happens if I increase our n? And inside this bracket, your x equal a means 0. What do you get? Will it converge? Okay. Will it converge? What do you think, Edmund? Will it converge? Will this equation converge if your n is more than 1, when your x equal a?
Yes, sir, converge.
Why? You'll get what?
Get a converge.
Yeah, you say converge, right? Converge, it must arrive at one solid number, right? You add all these numbers together when we're using this equation, right? What is the final answer if you want to add this power series, all the numbers together until infinity? But in the case of x minus a, when your x equal a, what is the final number you get? Shakir, you want to try? What is the final number? What is the, if you want to, if the question asks you to get the sum of all this equation, and your x equal a in this equation, and you increase the n from 1 until infinity, what do you get from this equation, Shakir?
Sorry, sir?
If you look at this question, you know that this is power series, right? Okay. You know that this is power series, right, Shakir?
Yes, sir.
You understand that this is a power series, right?
Oh, yeah.
Okay. Now, just now we explained to you, when your n is 0, you get 1, right? In this equation. When your equation, you look at the far left, Cn bracket x minus an, when your n equals 0, you get 1, right? You get 1. And no matter, and even we use x equal a, you get 0, right? 0 power n, you still get 1, right? Correct? Now my question is this one. What happened to this equation if you use x equal a and you want to add all these numbers together by increasing your n? Means you count from the first number until the last number. What do you get? Do you get a converge pattern or not? Or you get a diverge pattern? Just try a simple test using this equation. What do you get? Start with the first one. If your n now is 1, if your n now is 1, so the equation of the power series, now what you get? What is the equation you get? Cn bracket x minus a power what? The first number. By looking at this requirement or this request, what do you get? Do you understand what I'm asking you?
Converge.
No, what do you get? Give me the equation, what do you get? You see my mouse, right? Okay, now my n here, this is the equation I want you to calculate for me. Now I want you to increase your n, become 1. What do you get as a result? When your x equal a. X equal a, what do you get?
0.
0 power what?
0 power 1.
0 power 1, what do you get?
0.
0. 0 times Cn, what do you get?
0.
0. Okay, so this is the first number. Help us to continue second number. Continue to use this equation. Just now the first number 0, right? Now you increase the second number. N equal 2 now. What do you get?
Still 0.
Still 0. Then the third number.
Still
What
0.
do you get? Does it converge? Does the data converge? What do you understand about converge and diverge?
Converge is like when you increase the
N.
when you increase the number, when you increase n, the number will like become closer to
one
like
number, right?
One number.
So
while diverge is like
infinity, right?
Infinity.
Okay. Now think back what you calculate just now. The first number, what do you get?
0.
0 plus. What is your second number?
Still 0.
0 plus. What is your third number?
0.
So 0 plus 0 plus 0 continue to plus 0. What do you get?
0.
So does it converge or diverge?
Diverge.
Still diverge. Again, rethink what is the convergent definition. 0 is a value, right? You continue to get 0. Do you get converge or infinity?
Oh, converge.
So if it n more than 1 or equal 1, continue to calculate with x equal 1, you continue to get 0, right? The answer is converge. Because if you plot graph, you continue to get 0. And if your answer is diverge, means the continue until you will get infinity.
Oh, yeah. Okay. I can imagine like the graph now.
Yeah, because it asks you to series is a continue to calculate. It continue to add number. So so if you continue to get 0, Second number, you also get 0. Third number also get 0. So you 0 plus 0 plus 0 continue to add, you still get 0. So if you plot graph, you'll get a 0, 0, 0. The dot will land at 0, 0, 0, 0, 0. So you'll get converge. Okay, Nizam, you get the idea? Nizam expert already lah on converge and diverge. Okay, Nizam, does that make sense to you if I say if under this condition you get a converge scenario?
Yes.
Agree, huh? Edmund, you agree?
Yes, sir.
Okay. So you'll get all is 0, like what what our friend Shakil explained just now. You get every time you get 0, so you under converge. Okay. Okay. Continue. So is there any other way besides we substituting the number to see whether it's converged? The answer is yes. You can use a test called root test. There's one test to do to see whether it's converged or not. For power series, there's one test that you can do. The name of the test is called root test, or sometimes you will see other textbooks, you will see ratio test. Okay, what is root test and ratio test? Or I will use root test. I will use root test most of the time. The name, sometimes I use ratio, but most of the time I use root test. When I mention root test, means we are going to test the power series, this whole power series, or this one or this one, as long as it's power series. Anything that x power something, it fall under power series. X power something, you see the equation x power something, it fall under power series. And how do we test the power series, whether it's converged or not? We use the name for the test is root test. Now I will let you know. I will show you the equation. So what is root test? This one you just need to memorize or put this somewhere in your notes. Just it's like a handbook, or it's like a reference material. So as long as you want to do root test, there are 3 equations that you can use. Okay, first one is this one. Okay, you take a sub n plus 1 means the second number, divided by an means the first number or the previous number, means n plus 1 is, let's say n plus 1 is the second number, n is the, let's say, is the first number. So it means is the position of number. The a sub n plus 1 is a position of the number, and the n is also position number. If your n plus 1 is the number after, okay? So n plus 1 and n, make sure you know how to read or what is the meaning of an plus 1 and an, okay? All right. So if you do the test, if you use this equation to test, you get one final number, the L. So if you don't understand what is L, go back to the previous video when you explain about convergent, divergent. Okay, L means one solid number. In this case, if you do the test and you do the limitation calculation until infinity, you get less than 1. If you do the ratio, you take the second number divided by the first number, and the ratio is less than 1. You can say that the sum of the first series, the an, is converged. Okay, so this is the first rules under root test or under ratio test. If you meet the criteria, this first criteria, then you can use this equation to continue calculation. Okay, how you apply root test? You apply this equation, you get results. If your L less than 1, you can continue to calculate using this one, an. Continue to calculate, and is sure to be convergent. Okay, I will not show you how to. There's a step of proof this one, but I will skip that one. If you're interested, you can go to Moodle. I already upload the attachment inside Moodle under reference or under miscellaneous folder. You can go there. There's a document proof this one. Okay. Another two, you can use the second equation. If you do the calculation of this one, you take the first series divided by the second series divided by first series, and you arrive at and you use the limitation to infinity. If the final answer you get is more than 1, or you get infinity, then the series, the power series, is diverge. This is the test that you can do. So this screen here, this PowerPoint slides here is important when you want to prove whether the power series is converge or diverge. You can use these rules to help you. Okay. This is the third set. Third condition. First condition, you use this equation. You get less than 1. If the number less than 1, sure it will become converge. You use this equation, you get more than 1, you get infinity is diverge. The third condition, if you do this equation, a sub n divided by an, means you use a second series divided by the first series, you stop at 1 or you get 1, although it's a solid number, but if you do use this equation to count, you get 1, it means you don't need to continue. There is no conclusion whether it is converge or diverge. You cannot say whether it is converge or diverge. It depends on the situation. It depends on the equation that you see in the power series. So there are 3 conditions under root test. Either it's converge, diverge, or there's no result. Inconclusive means you don't know whether, you're not sure whether it's converge or diverge if you get this scenario. Important, huh? This one is important for your test 1 and also coming quiz. Huh? This slides is important, again, I stress second time. This slides is important for incoming test and quiz and even final exam. Okay, there will be one section asks you to prove the power series is converge, diverge, or inconclusive. Use these slides, this information to do calculation. At the end, you arrive either less than 1. You'll see your answer either less than 1, more than 1, infinity, or equal 1. Then you use these slides. This called root test to say, oh, you use this equation, you arrive less than 1, so the series is convergent. Or you get this answer, you say, oh, the question asks you to calculate, the series is divergent. Or when you get 1, when you use this equation, it is conclusive. We don't know whether it's converge or diverge. Clear? This is just like a manual that you can refer to. Okay, this is a life jacket for you. Remember these 3 conditions when you want to deal with power series. Let's look at one example. Okay, right. Now this example, it asks you to calculate a series from 1 to infinity. And again, how do you know that you are looking at power series? There's always an x there. There's always an x inside the question. And this question asks you whether it's converge or diverge. So remember just now I showed you 3 conditions or 3 equations just now. So we want to test whether this one is converge or diverge. How do you do it? You write the first equation. You copy the question. Sum of n from first number until infinity, and then the power series equation, x minus 3 divided by n, x minus 3 power n divided by n. You write equal to sum of an. These steps first give you the first mark, 1 mark for saying that you understand that this you can write in an. Okay, now these steps give you 1 mark. You copy the question to test whether it's convergent. First step is you copy the question, put the equation as an. Any questions so far? Nizam, okay? So far, anything you're not clear?
Okay, sir.
Okay, good, huh? All right, first step, I already showed you there. This one first step will give you the first mark. How do you solve? You look at the question. The question asks you whether this series will converge or not. So again, flip back to the 3 equation root test slides just now. This one. There are 3 equation here. The question asks you whether it's converged or not. So you look at the first one. You just copy the whole equation. If limitation n to infinity, the goalpost a sub n plus 1 divided by an equal to l less than 1, then the series, the sum n 1 infinity an is converged. You copy this whole thing, this whole statement in your answer, you get the second mark, second point. Okay, this one will give you 1 mark. Again, in test, you write second one, third one to me, I also didn't give you marks. Okay, in test, we want to test whether you understand or not. Do you know how to use the correct equation? Okay, so this is a reference for you. If the question asks you to test whether it's converged, copy the correct equation. This is the correct equation for the example number 17. First, again, first step, you convert the equation into an. Second, look at the question. The question asks you whether it's converged or diverged. Copy the correct root text, the root test equation. This is the first one in green color just now. You copy the whole equation from the if until convergent word. This whole thing, you copy and paste into your answer sheet, you get the second point. First mark, second mark. Actually, don't think one. This one you don't need to think one. Only you need to know what is the steps to solve power series equation. Always the first step, convert the equation into an. You get the first point. Then the second point, use root text to prove converge or diverge. If the question asks you to prove is converge, copy the equation that relate to converge. Okay, this one don't need think one. You just need to know which one to use only. First point, second point. Then you look at your answer. You compare an equal to equation s minus 3 power n divided by n equal to an. You write in your answer. Okay, you write in your answer there. Okay, then you increase the an because in this equation, in this blue color convergent text, you need a sub n plus 1 and a sub n. So the first an you already have already. An equal to this equation. Then how to get a plus n? A sub n plus 1. How do you get this one? You just change the n here, this one. You just change the n here, become n plus 1. And then the n here, this one n, become n plus 1. Any question? Any of you don't know how to convert this information into these 2 red color answer? Any one of you don't know how to convert a plus n? You don't understand how you get this one? Edmund, you
So
okay?
can you repeat again?
Who is asking? Shakir, is it?
Yes.
Okay, Shakir, you understand this one, right? This statement, the blue color, this one, right?
Yeah.
Okay. Under this test, you need 2 number. You need 2 series to test. You need the a sub n plus 1 and a sub n, right, Shakir? You need 2 set number here. And inside the goalpost there, you need 2 set number. Correct? You understand this one or not, Shakir? You understand the goalpost? Inside goalpost, you need two set, one above, one below, the top and below.
Okay, yeah.
So you in your answer just now, you already say that the AN equal to this one. You understand? AN equal to this one. So you have the below already. You have the below AN already. AN equal to this equation. Now, how do you get the top one? How do you get the A sub n plus 1? You only change the n. You need change the n become n plus 1. The equation doesn't, the general structure, it didn't change. X minus 3n, right? Now what you want to get for n plus 1? You just change the n become n plus 1. And then what happened to n? Now you want to look at the A sub n plus 1. So you change n become n plus 1. You compare these two answers. Do you have any more questions, Shakil? You compare the left and right. You actually change the n. You actually change the n only. Do you see it, Shakil? Do you see it?
Yes, sir.
Okay. Nizam, you okay? You know how to write these two equations or not, Nizam? AN and A sub AN plus 1.
Yeah, got it, sir.
Got it, huh? Okay. Edmund, you okay? Huh?
Yes, sir.
Okay. So first step, copy the question, equal this equation as AN. Second, look at the question. The question asks you whether converge or diverge. The question already point you to converge. So go to the PowerPoint slides just now, the black PowerPoint slides with 3 conditions. Copy the converge condition into your answer, you get a second point. And from this one, inside the goalpost, you need 2 sets of data. You already get the AN equal to this one. You need to rewrite the second one, the new one, the top one. A sub n plus 1. How do you change the AN to AN plus 1? You just change the n. You just change the n. Okay, you just change the n. From the equation here, you just change the n. N become n plus 1, n become n plus 1. Okay, once you get this one, you get the third point. 1 mark here, 1 mark here, 1 mark here, 3 points. Sometimes I'm generous, I give you 1 more point for here. 1 point for each. But normal, I will just give you 1 point for to show that you understand what is AN and A sub n plus 1. Because I did give you marks for AN in the first section already, first steps. So 1 point, 1 point, 1 point, 3 point. The next step is just to use this root text to prove what number you get. So you put the 2 number together inside the goalpost, the tiang, the goalpost. So you already have an AN equation. AN, n plus 1 and the AN. The next one is just a basic mathematics. You just put them into inside the goalpost and do calculation. So this one is AN, n plus 1. You copy this one, put on the top. And then the AN is below, so you flip the number. You'll get n divided by x minus 3n. This one actually is AN. You just flip the number. Or you can write 1 over this whole thing, and then you flip the number, you will get this one. Okay? Anyone have question on this one?
No, sir.
Okay, good. So this actually is a very, very basic, just substitution of number. Okay, then the next is just rearrangement of equation here. All right. So I put the equation on the top. So the next one is that you put in the limit, because this equation, this root text, come with a limitation. Limitation for you put in the limitation to do calculation. So from these steps, the next step is to put in the limitation until infinity. You will get this answer. Okay, you'll get this answer. How to get this answer? If you look at the far left, okay, if you look at the far left, what will you get on this one, the first one? Okay, the first one, this one. What happens if you increase to your n to infinity? Below 1, you'll get infinity, right? Shakir, do you see it? If you increase your n, the below that I'm pointing here, this one become infinity, right?
Yes, sir.
Okay, then this one, x minus 3, no matter what inside the bracket there, if you increase your n, the power n, the number on the top here, the full set on the top here will also get infinity, right? So infinity divided by infinity, basically, you can say it's 1, but mathematician, they have argument on that. So infinity divided infinity, so basically you get 1. You only left out this one. And, or you can do mathematic cancellation also lah if you want, okay? So if you do cancellation, you arrive at this equation, okay? So you'll get 1 divided by 1 plus 1 over n and plus this one. Okay, this basically is just a rearrangement of equation, then you arrive at this one. Yeah, from here to here. Okay, I think I have some steps for you. So I draw an arrow there. So basically you see this one, right? X minus 3 power n, and basically you can cancel the set of x minus 3 n there. So you cancel. I draw the blue arrow for you. You cancel n. Basically you just cancel the equation. All right. Then you left out with x minus 3 power 1. Okay, algebra, this is algebra. So if you're weak in algebra, something that power something, that one you need to go back to the advanced mathematics or calculus 1 or mathematics 1 about what happened if you have plus, minus, and so on. What happens something, power something. So you need to look back at the textbook. So that's why here I can cancel this one and the n here. Okay, then when I cancel, I rearrange, I get my equation like this. So I continue to do my limitation calculation. So what happened if I increase my n here to become infinity? 1 over very big number, I get nearly 0 here. 1 divided by very big number, I get 0.0000001. So this one basically is a very small number, so I can cancel. Basically, very, very near to 0 if your n is infinity. So this is 0. 1 divided by 1, you get 1. So you arrive at goalpost x minus 3. So this is your answer, x minus 3. Okay, so he asks you the value of x, inside this equation so that it converge. You look at the test that the root test that you copy from the slide just now. Your final answer must less than 1, meaning that this whole thing, x minus 1 goalpost must less than 1. So you apply this set of test statement to your calculation. Okay, you combine this one and this one to get convergent. So this one must less than 1. L, basically this L is what you calculate lah. So L is x minus 3. So you take this one, less than 1, then you calculate what is your x. Okay, again, I highlight for you. So you write the goalpost x minus 3 less than 1 is the final answer. Or you can put your answer as x minus 3 either less than 1 or 1. Okay, you can change you can rewrite. Either you put in the goalpost as it is, this one less than 1, or sometimes the question will extend to ask you to say the exact location of the x. So in this case, you can write you remove the goalpost from this one to this one. Meaning if you remove the goalpost, you can write in second pattern here. These two is the same, the two yellow box there, either the first one or the second one. They are the same meaning. They are the same meaning. If you remove the goalpost means the x minus 3 will between 1 and minus 1. Then you do a further calculation again. You move your minus 3 to the left and right. Okay, you move your x minus 3. There's a minus 3 in the middle. You move your minus 3 to the left and right. On the left, minus 1 plus 3, you'll get 2. On the right, 1 plus 3, you get 4. Yeah, so you change this one equal to this one, this box equal to this box. You write this one less than 1 and rearrange the mathematics. You remove the goalpost, you will get between the minus 1 and 1. And then you rearrange the equation, because if you write in the second yellow box there, it haven't complete, you need to remove, make sure that at the end you only have one x number in the middle. This is just in the middle. It doesn't complete, it's not a complete answer. So this is more complete. Okay, so the exam or test, we expect something like this and not this one. So if the answer is 2 marks, you stop at here, you already get 1 mark. We are expecting something like this. X is between what and what. Okay, so you need to remove the goalpost in test or final exam. Don't stop here. If you stop here, you only get half of the answer. If the marks is 2 marks, you stop at the goalpost answer, you only get 1 mark, 50% of the marks there. Okay, so basically this is let's count how many marks we can, basically this question will give you. Okay, I show you. First marks, to show that you understand to convert equation to AN, first mark. Second mark will be whether you know what is root test or not, and then you compare to the question. The question asks you to test whether it's converge, so you use the converge scenario, the first criteria. So you copy the whole criteria, you get the second marks. Then the third step is calculation steps. This here can give you 2 marks here. So first, we want to see whether you know how to do calculation. AN and N, just now, right? So this is the second mark, the third mark. 1 point, 1 point, 1 point, and then you do substitution of number. Do calculation for algebra, for your algebra. Rewrite the equation. Step will give you 1 more marks. And then you do the limitation. Up to here, you get 1 more marks. And then the final answer, 2 marks. So you compare this one and this one. You write this one. This one will give you 1 mark. Goalpost x minus 3 less than 1, you get 1 mark. If you stop here, you don't get the final marks. You need to write in terms of x equal to what. So you rewrite, you remove the goalpost, you get the range between minus 1 and 1. It always follow the number. If the goalpost less than 2 means it's between minus 2 and 2. If the L is less than, but anyway, this one is standard already because you are using rules, you are using ratio test. You always less than 1. So basically from this step to this step is standard. Only change the equation that you get. This one will change in exam or test. So it always less than 1 if you use root test, just for your info. Okay, so here to here is the standard steps. Only you need to change the equation that you get from the calculation. And then you do a little bit more calculation. You remove the x minus 3, the minus 3 you remove. So you move to the left and right. Then you arrive at here. So basically this kind of question give you about 5 marks or 6 marks, right? Kind of question. And this one, just beware. Your quiz or test 1 is near. So maybe I'll give you quiz for the next class or this week. This week, just prepare. I will give you quiz within this week, so get prepared. So yeah, so yeah. All right, so this one I will, example 18, I will attach in the PowerPoint slides. You go through, all right? So we won't go through in our lecture today. So however, the information that will be inside the PowerPoint slides. This is just extra example. So go through. Again, use the root text and so on. All right. We go for another 2 or 3 more slides, then we stop. Okay. Another one is interval convergence. We look at one more concept, then we stop. Interval convergence. We have one more theorem here. Theorem means truth. We have come to the fifth one, the fifth theorem. If your power series, again, this is a general equation for power series. Cn x power n means you are talking about power series. You have 3 possibilities. Okay. 1, converge. The power series will converge when x equal a, you will get converge. Second, power series will converge for all the x. This one, the series, this one, power series will converge for all the x, means if you change the x also, it will converge. There are 3 possibilities. Second possibility. Third possibility, it will converge. Third possibility is the one that we see when we change the x here into x minus a. So it will, if x minus a less than one number, for example, the L, right? Less than one number, a positive number, then it become converge. If it's more than the number, then it diverge. So this is also another reference for you when it comes to test or maybe quiz or final exam. So it will tell you whether your power series is converged or not. Okay, so this is a general condition. You look at the question and then you compare the first one, compare the second one, compare the third one, whether it meet all these criteria or not. Then you use the root test just now. The root test also have 3. So these are the important 2 slides. Okay, these are the important 2 slides. You compare first condition, second condition, third condition. Okay, so the theorem means it's a truth. It's a truth in mathematics. So normally power series have 3 conditions. 1, 2, 3. Okay. I give you one more example, then we stop. So find the radius of convergence and interval convergence of this series. So let's say you're given a series, again, series in the pattern of this one. How we know it's series? Because we have a sum symbol there. Okay, so sum symbol here. This is a sum symbol. If you're seeing sum symbol. This is a sum symbol. So sum symbol means you are talking about series. And if you talk about power series, means you'll see x in the equation. This is the x that you will see. This is the sum, means series. Series means you add things together. All right. Yeah. You see x means you are talking about power series. How do we solve? First, again, I hope you will see the SOP, the standard operating procedure in the mathematics for power series. Can you see that we keep repeating the steps? The first step will also write what is our AN. So keep in mind when you practice power series exercise, first step always write your equation in AN. Okay, so this one equal to AN. Sorry, I think I missed out the sum symbol here. So actually you should add in the sum symbol and then equation equal to sum symbol AN. The meaning is that your AN equal to this one. Yeah, there's something missing in my equation here, which is a sum symbol. All right, I apologize for that. So there is a sum of symbol here. Basically, the idea is just to write this, the question the whole question, red color, this one, in sum of AN. This gives you the first one. Second, you know that you root test, you need to, of course, the second step is to write the root test. Okay, to write the root test, but I skipped the step already. Okay, then we repeat to find the AN and A sub N plus 1. This one, I think Shakir already explained already, how to find the A plus N. Correct, Shakir? You know how to get this one already, right?
Yes, sir.
So basically, you just change the N become N plus 1. So you get your AN, you get your AN plus 1, then you do the root test. Okay, this is just a rewrite of the equation. Then again, you write the goalpost with the A sub N plus 1 divided by AN. Substitute these two equations inside here, rearrange. Basically, from this step onward, it's just a rearrange of the equation. But important concept is that write your AN, write your A sub N plus 1, write the goalpost and the equation. Next substitution, rearrangement, and you arrive at one equation. Next, you use the limitation to find the answer. So this is just steps for you. You can go back to these slides later on. So basically, you just understand the steps, understand what we're trying to do here. Okay, because in exam you won't see the same equation anymore. What you need to know is that what is the first step you do, what is the second step you do, what is the third step you do. Okay, then you rearrange again and again and again, you get your X. In power series, remember, you always need to contain your X. You only need to contain your X with the goalpost. You cannot pull your X outside the goalpost. Always keep your X in prison, okay, between the goalposts. You treat your X is like the goalkeeper. You cannot go outside the goalpost. Okay, so this is the interesting part of a power series. You always keep the X inside the goalpost, like the example just now, right? So you continue to do. Next step, you just put in, after you get the goalpost A sub N plus 1 and AN, you get this form. Next step, you add in the blue color limitation. After you do the rearrangement of equation, you put in the limitation and then see what happened to your equation here. So once that you put in the limitation, sorry, this one I think I missed out the X here. Okay, this, yeah, no, X is here. Okay, good, X is inside. So again, how do you process the information here? Increase the N, what do you get? 2 over very big number. 2 over very big number, actually you will get 0. Okay, 2 over, let's say you imagine and you press your calculator, 2 over 1 million, you get 0.000 something. So it's very, very small number. Near to 0, you can cancel. On the top also, what happened to N near to infinity? 1 over 1 million, also very, very small number, 0.000. So you can cancel this one. So basically cancel this one, cancel this one. 1 divided by 1 square root, you still get 1, right? So you square root of 1, you get 1, right? So after that, you rearrange, you get 3 goalpost X. 3 goalpost X, after this is your answer for limitation steps. Then recall the root test. Or previously, you already copy in the second steps. Once you have your AN, you copy the second step for convergent. All right. We know that this is the step you just copy from the PowerPoint slides. You know that this is at the end, this number, okay, this number, 3 goalpost X will less than 1 to get convergent. So you just combine this information and this information, you get this one, so that your data is converged or your series is converged. Move the 3, just rearrange the inequality there. Move the 3 on the left to the right, you get 1 over 3. How do you remove the goalpost? You just contain the number. Okay, you just contain the number. So in this answer, it means that the radius of convergence is 1/3. Okay, so in this case, your x goalpost, it means that your x will always positive, right? Goalpost means, let's say you -1 goalpost means you always get positive number. So in this case, your radius of convergence is 1/3. Any question up to this stage? Any question?
No, sir.
Okay, so Edmund, you okay? Nizam, you okay?
Yes, sir.
Edmund, okay? Nizam, you all right? Nizam, are you there? Nizam? Okay. Okay, I think we stop at here. Then we continue our next class, which is tomorrow, 12 p.m. 12 p.m. Let me stop the recording.
Okay, sir. Sir, regarding the